When you ask Claude to generate structured data, like JSON, code, or a list, it tends to be helpful in a way you don't necessarily want. It wraps the output in Markdown, adds explanations, maybe a sentence at the start and one at the end. This is great in a chat, but if you're building an app that needs clean JSON to plug into something else, that creates friction. How do we get just the data? The official course has an answer. We'll cover it, but not because we'd recommend it. The technique it teaches was always a workaround, and the API has now officially closed the door on it for current models. Most of this video, though, is about the right way to do it that unfortunately was never covered in the official course. As we go through the video, we are going to look at 3 lesson files. They all solve the same problem in different ways. O4 structured data legacy.ts is the official course approach, ported to TypeScript. It's getting blocked on newer models, but you may encounter this pattern in older code, so it's worth being familiar with. O4 structured output.ts demonstrates the modern approach using the SDK's structured output support. O4 tooluse.ts shows the tooluse API being used as a structured output mechanism. We'll dive into tooluse properly later in the course. Here, we just demonstrate how it can be used to structure the model's response. Here's what the official course teaches. The trick is in those 2 lines before the API call. First, we add an assistant message. Not a real one, we are injecting a fake message into the conversation. It opens a Markdown code block, but doesn't close it. Then we pass a stop sequence, the closing triple backtick. Since Claude essentially generates the most likely next word, it continues with the code after the code block Markdown and stops when it tries to close the block. Yes, it works, but look at what's actually happening. The messages array is designed to represent a real dialogue. Injecting a fake assistant turn to manipulate the model's output is exploiting that structure, not using it as intended. And the stop sequence for a closing code markdown is a bet. You are betting the model will try to close the block in exactly that format. More importantly, what you get back is a string, not a validated object. A string that you have to parse yourself, hoping the model didn't hallucinate a field name or drop a closing bracket. In this lesson, we also use a dedicated model variable instead of model variable from settings. That's intentional. The model here needs to be one that still supports assistant message prefilling, which is a shrinking list. Try it with the current model and you're likely to get this error. The API is very clear about it. If Claude Haiku 4.5 is no longer available, the lesson 00 query model list.ts can show you what models you can choose from, but there is no guarantee any model will support this by the time you watch. We ported this lesson for completeness, but this is the museum exhibit section of the video, so moving on. The modern approach to the same task is in lesson 04 structured output.ts. No fake assistant turn, no stop sequence, no string parsing. What we do instead, we define an actual schema, pass it to chatStructured, and get back a typed JavaScript object. The schema here says, give me a commands field that's an array of exactly 3 strings. chatStructured lives in shared.ts. Let's look inside. 2 things to notice here. First, this calls client.messages.parse rather than client.messages.create, a different endpoint with structured output support built in. Second, output config with JSON schema output format is where the schema goes. It wraps your properties into a full JSON schema object, marks all fields as required, and disallows extra fields. The return value in response.parsed output is already a JavaScript object, not a string. Notice that the lesson passes temperature set to 1, so that the content of the commands is generated creatively, but the structure still remains deterministic. And let's dwell on this for a bit, because it explains why this approach is fundamentally different. When Claude generates text normally, at each step it calculates probabilities for all possible next tokens and samples from them. With JSON schema output format, something else happens. Before sampling at each step, any token that would make the output violate the schema is removed from the pool. The model can only pick from tokens that keep the output schema compliant. The schema isn't checked after generation, it's enforced exactly during it. That means the output is guaranteed to match the schema. Not probably, it's a contract. Schema mismatch is structurally impossible, not just unlikely. There is no retry logic needed. The model can't hallucinate a field name or forget a closing bracket, because those tokens get ruled out before they would even be considered by the model. The variability still applies, but within the schema's constraints. That is, which commands get generated, how they are phrased, how long they are, may vary. It does not affect the structure though. And there is one trade-off. The schema has to be compiled into a grammar before generation starts, and that happens server-side at Anthropic's end, not in your TypeScript code. Your SDK just serializes the schema and sends it with the request. For simple schemas like this one, the compilation is fast. For very complex schemas, it can fail before generation even begins, so keep schemas as simple as the use case allows. The third file, 04tooluse.ts, takes a different route. We didn't look into tooluse yet, so we won't go into too many details here. In short though, we define a tool with an input schema, and tool choice set to type tool name output commands forces Claude to call that specific tool rather than responding in plain text. The result comes back in response.content as a tooluse block, and you pull the structured data from its input field. Worth flagging, there is no actual tool here. No function gets called, no side effect happens. We define a tool purely to use the mechanism. The tooluse API accepts a custom schema and returns structured data as a tool call, but the call itself goes nowhere. It's using the scaffolding to get structured output, not to invoke real functionality. We'll see tool use with actual function calls later in the course. The schema we use here is identical to the structured output version. Same commands array, same constraints. That's not a coincidence. Tool use also uses constraint decoding to guarantee that the tool input matches the schema. Same mechanism used by different parts of the API. Another good reason to cover this approach now is the fact that tool use predates the structured output in Anthropic's API, so you may see this pattern used for structured data extraction in older code. Use npm run dev to run each of the 3 lesson files. All 3 print the same thing, 3 AWS CLI commands, 1 per line. The commands themselves will likely differ between runs, since the content is still up to the model, but the structure is the same every time. Notice that the code path to extract the result is different in each case. The legacy version gives you a trimmed string. The structured outputs version reads result.commands from a typed object. The tooluse version pulls tooluse.input.commands from a content block. Same printed output, 3 different routes to get there. Here we go, 3 ways to get structured data out of Claude. One that was always a patch, one that's the right tool for the job, and one that does it as a side effect of tool use. The constraint decoding behind the latter 2 is where the value is. It will come up again when we cover tool use properly. This is also the last video in the Accessing Claude with the API section. We've covered the basics, sending messages, maintaining conversation history, streaming, and structured outputs. See you in the next section.